Okay, so let's see how we can use that definition of right triangle trig, right? We define all our trig functions using a right triangle. How can we use that to solve this triangle? All right, so I want to find all my 6 angles. I want to find sine, cosine, tan, secant, cosecant, and cotangent of theta. Right? Now, one of the things we notice here is I'm given 2 sides. I'm given the side A, which is 3. I'm given the side B, which is root 7. I'm not given side C. So the first thing I need to somehow figure out is what is side C? Well, it's a right triangle, so we can use the Pythagorean theorem, right? So, and I know that A squared plus B squared equals C squared. Okay? What is my A? A is usually the side, small a is the side opposite angle A, which is 3. So this is 3 squared. Plus B is the side opposite angle B, which is root 7. And I'm going to square that. And that is equal to C squared. Okay. So 3 squared is 9. Square root 7 squared is 7 equals C squared. So I get 16 equals C squared. So what is C? Remember, I don't want C squared. I want C. So what is C going to be? Well, C is going to be square root of 16, and that is equal to 4. So this side is 4. And now that I have all 3 sides, I can go ahead and use my definitions for my function. So I know that sine theta is going to be opposite over hypotenuse, which is equal to, what is opposite is 3, hypotenuse is 4, so this is going to be 3 over 4. Okay, now notice here that sine cannot be negative because I have sides of a triangle and I cannot have negative measures or negative lengths, right? So in this case, my triangles are going to come out to be positive, or my function values are going to come out to be positive. Okay, then cosine theta is adjacent over hypotenuse. And this is going to be equal to adjacent, which is root 7 over 4. Okay, tan theta is going to be opposite over adjacent, which is going to be opposite over adjacent, which is 3 over square root 7. I don't mind you leaving your answer with a radical in the denominator, but let's say you were giving a CRT. This would be usually in rationalized form. So instead of 3 root 7, you could also think about this as 3 root 7 over 7. For this exam, I would accept either one as an answer. Okay. Then we have cosecant theta. Now, I technically don't need it as hypotenuse over opposite because I know this is 1 over sine theta. And so that is 1 over 3/4, which is nothing but 4/3. I know secant theta, which is root 7 over 4. Oh, sorry. Secant theta, which is 1 over cosine theta. And we know that is going to be 1 over root 7 over 4, which is 4 over root 7. Or, again, I can write this as 4 root 7 over 7. And then finally, I have cotangent of theta, which is 1 over tan theta. And that is 1 over tan theta is going to be 1 over 3 over root 7, which is root 7 over 3. So these are all the values of the 6 trigonometric functions for that particular triangle.